Fellow PokeProfs, ChatGPT is the fastest growing platform in history and now has over 200 million monthly active users. 99.9% of those users probably don't understand, even at a superficial level, how ChatGPT works its magic. After watching this video, you will be one of the few elites that can explain how ChatGPT works. ChatGPT is an advanced AI language model and chatbot developed by OpenAI, designed to engage in text-based conversations with users. With its remarkable ability to understand and generate human-like text, ChatGPT has garnered significant attention for its potential in various applications. It works via a system of computer brains, complete with interconnected neurons that can fire together. These brains are neural networks, and they are supposed to model how the human brain works. There are three things that make ChatGPT stand out among other neural networks. First, it turns words to numbers. Second, it turns numbers into ideas. Last, it turns ideas into the next word. Let's consider this prompt for instance. How does ChatGPT work? Are you ready to learn what happens next? Suppose I ask you to multiply these two numbers together. You probably know that the answer is 18. How would you cope if I were to ask you to multiply these two strings together? It's not easy, right? Same goes for a computer. A computer can only understand numerical data such as integers, floats, and vectors of floats. That's why we need to convert words into numbers before we can do any computation with them. This is where embedding comes in. Embedding is a way of mapping words or other data into numerical vectors that can represent their meaning and relationships. For example, the word how could be mapped to a vector like, and the word does could be mapped to a vector like. These vectors can then be multiplied, added, or compared with each other to perform various tasks. But we can do better. What would be a great way to assign a vector to each word in the English language? Well, there are about 50,000 words in English that are not obscure. Each word is unique. So, how about every word being assigned a vector with a 1, where that word would appear in this dictionary of 50,000 words, with zeros everywhere else? This so-called one-hot vector is excellent. But we can do even better. I said that these 50,000 words are not obscure. After all, there are hundreds of new terms invented every month, and the number of all words might just be too overwhelming. ChatGPT uses so-called tokens to overcome this problem of scope. Namely, parts of words such as eon and ing are tokens in case a user decides to ask ChatGPT about a word that might be a word it already knows, but with ing appended to it. For example, ChatGPTing. It just so happens that there are also 50,000 tokens, which include 3,000 whole words, punctuation marks, etc. In summary, what does this mean for our prompt? First, it is tokenized. Then, embedding vectors which contain semantic relationships between words are produced for each token. This is like Porygon using conversion. The description for conversion applied to the concept of embedding could be something like the user changes its data type to become the same as the data type at the top of the list of texts it processes. To clarify, this sequence of vectors contains exactly the same information as the text prompt we had earlier. It was just converted into a different form, and that data type is a numerical vector. So, our "How does ChatGPT work?" prompt now looks like a good old random looking vector of ones and zeros. The GPT part of ChatGPT stands for Generative Pre-trained Transformer. This is where the transformer part comes into the whole equation. But by the way, these can all be summarized by systems of superbly sophisticated yet simple equations in the end. Now that we have vectors of numbers, we can now perform addition and multiplication. Yes, this is about how complicated it gets. Could this be how the brain works at a fundamental level? A transformer is a funnel of neural networks specifically adapted to handle natural language processing tasks exceedingly well. It takes the vector from before and processes with its artificial brain a vector of possible next token outputs. This output may be somewhat like how a human thinks of what next to say. For example, given this sentence, what could the final word be? It could be dog, it could be person, it could even be giraffe or dragon, but those are much less likely, unless the context is a fictional story, for instance, which is beyond the scope of this video. There is a minor problem though. Look at these three hypothetical prompts. Immediately, you understand the difference between them. One is an adjective, one is a noun, the other is a name. Of course, the user might not use the best grammar, but ChatGPT should be able to handle these prompts differently somehow. The solution is elementary. We add a position vector to the embedding vector from before. I'll take this opportunity to throw in another caveat. In this sentence, what is the antecedent of it? What about now? In this situation, when the antecedent is unclear, there's a nice tactic ChatGPT employs. One of Porygon's other signature moves is called conversion 2, and its description applied here could read as: the user operates on its vector to make itself resistant to the complexity of the text the target used last. Look at what happens when this move is used. All of a sudden, each possible pair of words can be considered by the transformer. For example, ChatGPT can now detect that bird it and plane it are the two possibilities with significant probabilities of relevance. Now, it is still unclear whether the bird or the plane is the one that continued flying. Fortunately, there is another pre-trained neural network that would be used based on all of the hundreds of billions of words that ChatGPT trained itself on to help understand the context. Most likely, in this case, the bird would be startled by nearly colliding with the plane, so it is probably more likely to be written somewhere that a bird would continue flying while a plane would simply be flying, since a plane can't take much of a break in midair. I have hinted at this, but A transformer works by a mechanism known famously as attention. In GPT-3, one of the more advanced models of ChatGPT, a transformer works on each token 96 times. During each cycle, there are a further 96 processing steps that happen in parallel to understand the relevance of every token to every other token. In the grand scheme of this, there are 175 billion different weights or parameters that each token is filtered through. The beauty of all of this, including essentially everything I've said up to this point, is that it produces an output that is reasonable by human standards. There is no theory of ChatGPT, in the same way that there is no theory of the human brain. All this while we simply tried, effortfully at any rate, to model the human brain for scientific purposes. Hence, ChatGPT is the product of research, and should be treated more as a scientific result, like penicillin, than as a product AI researchers decided to make because they wanted to see if they could become the most valuable company by market capitalization. ChatGPT is almost done after the transformers have worked their AI magic. I call it magic because at a glance, it looks like an average neural network. In fact, I even hinted that the whole of ChatGPT could be thought of as an entire system of mathematical functions. Yet, out of all this seeming arbitrariness, comes the unwaveringly convincing illusion of a human conversationalist. Accurately predicting what ChatGPT is going to say next is like trying to predict what the clouds above us are going to do next. There are some details I've deliberately skipped over, but the next main thing that happens now, considering the generation of the next word, is the creation of a new vector with every possible token. The whole deal with this vector is that each token now has a certain probability of being called to be the next token in ChatGPT's response. Moreover, there is a small amount of randomness so that the response isn't always the same for a given prompt. This temperature can be changed to make ChatGPT's responses more creative or more accurate. For example, the response to how does ChatGPT work could start with ChatGPT is a... The next word could be large, or language to be more precise, or chatbot if the temperature setting is set a bit higher. Of course, you can just ask ChatGPT to be more creative and get something like Genie. This is one setting among others that you can play with in OpenAI's playground. And the whole sequence starts again for the next token. In a single response, GPT-3 can output up to 2048 tokens, corresponding to fewer than 2000 words. At the same time, ChatGPT needs to recall all the context of the conversation and everything the user types in a prompt. If the prompt is too large, ChatGPT can get confused that the user could refer to something from the first sentence thousands of words later. For example, I've been asking ChatGPT to draft translations of Japanese voice lines from the Pokemon anime, but sometimes I need to remind it to do what I asked of it. ChatGPT definitely has a high attention span, but it isn't infallible. This version of ChatGPT, GPT-3, is perhaps more like Porygon Z. It is a remarkable development of impressive technology, yes, but it can behave erratically and may produce misleading, wrong, or nonsensical information without warning. How did you find that? ChatGPT turns words into numbers and processes those numbers like a human brain would process words. The chatbot satisfactorily converts the processed numbers to the next word. Let me know in the comments below what you learned and if there's a topic you'd like me to talk about next. I release a video about every month. If you appreciate the effort I put into making this video, please like and subscribe. PokeProfs, continue evolving.